Okay, well, first off, I just want to say welcome. Uh, I'm John George, and the rest of group members are Eduardo Rodrigues, Kevin Flett, and Sean Patrick Gillespie. So, first off, I want to describe the data set we found. So, we chose one of the preset data sets available to us in the rubric, and it deals with the Chicago energy usage in the year 2010. We found it on Kaggle, and it has dozens of variables and thousands of observations. And this proposed a question: how much energy throughout the city is actually consumed? We know Chicago is huge, and this data set seemed to take into account a good portion of the city. So we decided to dig into it, find some interesting correlations or relationships with the variables, and also create find some interesting conclusions based on several aspects of the data and the variables. Um, so the first thing that we should move into is talking about the data and the variables itself. And for that, I'm going to hand over the reins to Kevin for a moment.
All right. So the data set only contains information for 88% of the buildings in Chicago. So not the entire city, but pretty close to almost all of the buildings. Certainly a significant amount. The data gives energy used in both kilowatt hours and therms. And kilowatt hours generally represent amount of electricity, and therms represent about uh, natural gas used. Um, the data set also gave information provided by the census. So it described census blocks, building type, age, average stories, total square footage, um, population, housing, and occupancy. Um, so that not only could we describe usage by um, types of buildings, but also amount of residents that they contained. As far as the data cleaning is concerned, we began it using Google Sheets. Um, we created a dictionary tab where we would place the variable names of our renamed variables and descriptions for what those variables meant to make it clear for someone to re-examine our data set and understand how we came to the conclusions that we came to. Um, this After we were able to recode the variable names in Sheets, we then exported to a CSV with the rest of the dirty data into R so that we could recode a few of the variables. One of the initial names, or one of the initial variables that we decided to rename was the community area name, which is where in Chicago the building is. There were 77 community area names, which doesn't help with analysis. If you're not from the city, you don't know the specific neighborhoods. So we decided to aggregate the various uh, municipalities into overall geographic locations. To be specific, 9 bigger neighborhoods: the far north, northwest, north, central, west, southwest, south, far southwest, far southeast. And then we created a new variable called neighborhood, divided each community area into its given neighborhood, and then gave that a number. And then that number correlated to a value in the data dictionary that would, to a categorical value in the data dictionary that would describe the geographic region in which the neighborhood was located in. We also renamed the columns for electric access and electric accounts and gas accounts, which tells how many electricity accounts with kilowatt hours and how many accounts that included therm data in them there are in each building. Most of these values were numerical, but some of them were multiple strings. So, or strings that contain multiple words, which to do any sort of analysis on that, you'd need to recode them. So to clean them, we used a mutate command that would take all of the string values and create them into ones and zeros in new columns. And then we changed the less than 4 responses in the original accounts columns, since the true or false columns would tell whether they were below 4 or not. We also rearranged the columns to be right after original respective columns so that we could easily view the changes and comparisons. And then finally, a big struggle with this data set was the therms and the kilowatt hours, which you can convert between the two usages. And so we wanted to get a bigger picture of overall usage. And because so many of the uh, observations in the data set were split into where they only use therms or they only use kilowatt hours, I thought it would be useful to create an overall that just converted the kilowatt hours uh, into, or sorry, converted the therms into the kilowatt hours. And to do this, basically, I moved the data into an Excel sheet. And what I would do is I would write a formula for each of it, it would look at a column, and if it had data in kilowatt hours, it would just leave it and move it to the next column, which was renamed total, and then whatever the original column was. So January, therms January just became total January, therms max became total max. So if it had original data in kilowatt hours, it stayed kilowatt hours. But if it was in therms, it was then put into a formula that would, using a nested if statement, that would convert the value into therms. So that was how we cleaned the data set. For more on our graphs, I'm going to hand it over to Eduardo.
Cool. Um, so here for our graphs,
All right, quick thing. I got to hand off the remote control to you.
please.
Okay,
Okay,
sweet.
very good. So now I can control the web page. Okay, so here for our graphs, we see our pre-analysis plots. I'm not being able to control your screen yet.
There
Okay,
you
now
go.
it's working. Okay, now it's working. So for pre-analysis plots, this was something that just helped us understand what we're looking for. These graphs, we didn't use them much later, but this is, for example, the kilowatt usage for each month. Um, and then below this, we have total therms as compared to total kilowatts when they were two separate variables, and some regression lines. And then here we have the plots that we used to analyze our data and the graphs, starting with two different bar graphs. This first one is the average usage for each type of building. So it shows us that in average, industrial buildings use much more energy than commercial or residential. And below this, we have a bar graph with the total energy. And in contrast, we see that industrial buildings use a very small percentage of the total energy of the city. This is because although each industrial building uses a larger amount, as shown up here, we have a very small number of industrial buildings in the city of Chicago. And so the total usage of industrial buildings is not comparable to commercial or residential buildings. Further down, we have the explanation of which community areas are inside which neighborhoods. So we have number one, for example, is the west side. We have the population, and we have all the community areas inside um, the west side neighborhood. Part of our part of the cleaning of the data that Kevin was talking about. And after all this, we have the tables and the scatter plots that we used. So here, each neighborhood number is represented on this table from 1 to 9. Um, and here each neighborhood is represented by one of these groups of points. You can notice that these outlier points, the ones that are using more energy, these are probably the industries inside each one of those neighborhoods, while the rest of the buildings are cluttered together on these lines. And then we have the total usage in April, the total energy usage in April for each neighborhood. So as we can see in April, if we can take a look at neighborhood number 2, which is the central neighborhood, uh, the downtown Chicago, where all the commerce occurs, we can see that it's much higher than any other neighborhood. And actually, this number is about all the other neighborhoods added up. So what we can see is that in July, for example, the usage in all neighborhoods go up, and still neighborhood 2 is about half of total usage in the city. Of course, in the months of July and in the month of December, the usage is going to be much higher than in the months of October and April. And this is because of summer and winter and all the extra usage that comes with that. And so from these tables, we could understand which neighborhoods use more energy, and we could also understand which months use more energy. And so it was very helpful for us in order to continue to understand further all our data. And now, to talk more about the analysis, I'm going to pass the control.
Yeah. Come back. Yeah, I'll give it on.
All right, can I be heard now? Cool.
Yes.
Okay,
Yeah.
I can't unmute myself, but I can temporarily unmute myself.
Do you need me to take back the reign so that you can unmute yourself?
Yeah, you're muted. Still muted.
Oh my goodness. Okay, can I take that back?
Yeah,
Yeah,
no problem.
All right, and then if we want to, if you want to get this video into a video and then send it to me, I'll throw it in Windows Movie Maker and I'll just take out that section
For
of
sure.
confusion.
Okay. Yep. Well, I'm giving it to you now. Okay.
Okay, cool. Now I have control and we'll talk about the analysis. So originally, we ended up looking at different things than we kind of expected. But initially, we wanted to compare the per capita energy usage in the summer months in different neighborhoods, and important values for this exploration would have been total population in each neighborhood, total electric usage in each neighborhood during the months of May, June, July, August, both the numeric and continuous. And we do not need to use the entire data set for this exploration. Then we would also want to compare the per capita gas usage in the winter months between different neighborhoods in Chicago. The important variables here would be total population, once again, numeric and discrete, and the total gas usage during November, December, January, February. We do not need the entire data set either. Oh, goodness. Okay, sorry about that. This whole thing is all funky. Anyway, but the aspects of the data that contribute most significantly to energy use is kind of what we wanted to figure out. We wanted to create multiple linear regression models with all the variables to make sense of terms, how they might predict. We wanted to use the stepwise command. When we got into it, this didn't actually work. There was so much data that it would run forever and then cause an error. So we ended up just kind of looking in. We tried using most of the variables, and we did end up getting a pretty good linear model, but that is a bit different than what we expected. Oh, here it is. Yeah. We ended up using the average age of the building, the total population of the building type, the total units in each building, the kilowatt hours to square feet, the therms to square feet. That was our end AIC value, 1015914. And that was all pretty interesting. But what we ended up coming to the real conclusions about after looking into the data were these questions. We'll start with question 1, being which type of building average use the most energy. As we saw in graphs, industrial buildings use the most energy during building types. So one industrial building uses way more energy than any other type of building. However, in total, industrial buildings actually used a much smaller amount than residential or commercial buildings, just because of how many residential or commercial buildings there were compared to industrial buildings. Therefore, the total amount of energy used in industrial buildings is smaller, even though the total amount used per building is greater. We also looked into buildings using more energy during the summer or winter months and how much by the building type. And we actually expected it to be higher in the winter, as Chicago is quite a cold city. However, we found they on average use significantly more energy in the summer months, being June, July, August, than in the winter months, November, December, and January. Commercial buildings were up 17.9%, industrial 38.6%, and residential 27.8%. This was not the case with all building types. However, overall, most buildings used more in the summer.
All right, question 3, I can answer that one. And as we mentioned before, this is asking which neighborhood in Chicago uses the largest amount of energy in each month. And as mentioned before, Central Chicago uses about half the entire city's energy, and that's downtown Chicago, the Loop, near North Side and near South. And it's an incredible number when you take in count that it contains only 5% of the entire city's population. So yeah, it's neighborhood number 2, Central Chicago.
Yeah, and then question 4, which variables are most significant in predicting the total energy used for the year of 2010 specifically? As mentioned previous in the analysis section, include the average age of the building, the total population for the building type, the total units in each building, the kilowatt hours to square feet, and the therms to square feet. And overall, these were the questions that were answered, although if we were to take more time, we probably could go in and answer several more questions. However, this is the end of our presentation, and we appreciate the view, and thank you for watching.
Ta-da!